Hi everyone, welcome back to my channel. So as you follow me in this course, it's a computer vision, I mean Python for computer vision. But I have seen some comments indeed that this what I'm doing, it's not, let's say, a computer vision. This is 100% correct. But what my plan is to do a Python plus a computer vision, so you can have two courses in one with a comprehensive in Python and also in a computer vision. So, so far we have already covered how to set up your environment, working with variables, and also mastering strings, list, tables, and dictionaries. And you see how to access, how to delete, how to let's see, update the list, and also this data structures. And if you have been following along, you already have a strong foundation indeed. And most people skip, but you are building it the right way. So just try to follow this course and the playlist. I will recommend you not to skip any section. I mean any video, unless you're already familiar with what is going on. And also I recommend you just to do code yourself. See the video and try to apply it. I mean because programming languages is learning by doing. It's not just watching videos or reading books. So this is my opinion, because I have experience for more than 8 years in the industries. Okay, and today we are going comprehensive guide in a Python. Let's see, functions. And as I said, whether you are starting out with this course, or you are looking to level up your programming skills, understanding the function is absolutely essential. Function are the building blocks for any Python program. It's used. I mean, you can see it wherever you go. Functions, and also the next part. Let's see, the more advanced is the object. Object programming, I mean, object programming language, OPP, object oriented programming. So in this, also in this, I will teach you in a more advanced. So please keep in mind this video will be super long, maybe exceed one hour. And also this preparing for this tutorial, it took much time for me. So please, if you like the video, subscribe into my channel, like the videos. And of course, no doubt, if you have any questions, just drop down a comment below, I will answer it. If not, I will just try to make a video also for you, so to make it easy for you. This is our plan here. So now I will say what is the function, how to define the function, how to call a function, what are the parameters and arguments, what is the return value, what are the, let's say, variable scopes, lambda, dot string, recursive functions, decorator, generator, and I will cover everything in functions. So if you are, let's see, understand this 100%, I will just guarantee that you can program anything you can. I mean, without object oriented. But object oriented is needed for organize your code. But with with till now, after functions, you can consider yourself as a beginner programmer, I will say. And I will provide interview questions, and also what are the best tricks and which won't use which, and etc. So the functions are reusable blocks of code designed to perform specific tasks. Think of this as, let's say, mini program within your program. So instead of writing the same code over and over again, you can just define it once as a function, and let's see, call it whenever you want. Let me just give you an example. I'm just make a small code here. I will remove it. Let's say you have a list one is equal 1 2 3 4 5 6 7 8. I have an idea. Now let's see, you have the list two. It's fine with the same, let's see, content, but just to give you overview what I'm meaning. So let's assume that you would like to print, let's see, the list. So what you have to do is for item n list 1. Then you can see print. This we already covered in the list, but yeah, item. Now this is printing the list, the element of the I mean the elements of list 1. Now if I need to print L2 and L3, I just can do copy and paste. But do you think this is a good idea? And maybe I need it also to do it for this, because here I have 3 lists, so it would be somehow easy, right? But imagine you have thousands of lists. Would you repeat all of these code for loop? So the answer is no. This is the functions. This solved by functions. You can write one block and reuse it over and over again. So this is what we can see. So and some key benefits of using functions. Let me just remove this. I can also delete the block as well. It's they help organize our code into a logical chunk. So the function, let's say every function has to do a specific task, and they eliminate also one advantage is avoid repetition. So as you can see here, as you have seen, oh, I have deleted. I have right deleted, but because as you see here, I have repeat the for loop 3 times, and if I have 10 lists, I have to repeat it 10 times, which is doesn't make any sense. Let's say to repeat yourself, and also make code more easier to read and also to maintain. Let's say you have written a function, and for example to sum 2 numbers, right? And after a while, you need to change it to do minus 2 numbers. You just to change it a little bit, and this is make it easier and also maintainable, and also allow code reusable. You can use it, you can use this function wherever you want. So let's start with the most basic function syntax in Python. So I will see here how to do define function. You have to define def. With def is a keyword, and you can add here function name. The function name, it could be any name of you use, and here the code, and inside code to execute. And let's see, I need to print just as usual, print hello world, hello hello from a function. Now, let's see, this is a complete function, easy function, and just to show you the syntax, you have to add this def as a keyword, following by the function and this closing parentheses. This is the basic function. Let's see, and add this colon. I mean dots, points. Uh, well, no points, no dots. And this is the code you have to execute. Has to be intended in this lines here. I mean, you can see here, there's a tab from here to here. This is a tab, and now you have how to call this function. Just go out. I mean, go out from this function here. You can see now I'm trying to add a sentence here, so I can see this is calling function. So I can see function name. So this is the implementation of a function. This is the small, this basic stuff. So as you can see, keyword def tells Python you are defining a function. We give it a name followed by the parentheses and a colon. And the indentation code block that follows is the function called function body, and the code that runs when we call the function. So this function, it won't be executed until we have called this by, for instance, this sentences. So let me just comment this out here and try to run. See, I have to select the kernel, but it's super fast. Let's see here. I run it several times, but the function won't be executed. It's executed only when I call this function. So I have here function. You can see here hello from function. Now, as you can see here, if I need to call this several times, I can just not copy, but use this calling function wherever you want. So let's see here how many times it will be printed. So 1, 2, 3, 4, 5. You can see here it's printing a function. So this is, let's see, a simple function, how to call how to define the function. And the functions, there are two types, generally two types of functions. A function that doing something inside in the body of the function without returning anything, and a function that return, let's say, values. For instance, here the function is just printing the statement here, or let's say do the processing, and I don't need any return from here. And the other types of function is returning, let's say, a value. Do the execution, do the processing in this function, and give me, let's see, the output. The output, I might use it for as a entry point to another function or another. But don't worry, I will explain it in a more detail. So no worries about this. So now let's jump to functions with parameters. So let me just give me a minute. I have now just adding this table here, and there are, let's see, functions. Let's see. I mean, as I said, in general, there are only two functions. Let's see, types of functions: doing the processing inside the function and or returning the values. And here you can see the function with, I mean, no arguments and no return. So it means I have a function. I can it's not accepted. Let's see, any input. It's just doing output based on any stuff. We will see it, of course, in details, and also with arguments, and might be no return, and also with arguments and with return, and might be with multiple returns. So this we will see in very details. So let's start. Most of the function need to work with, sometimes we need a function to work with data. This is right? So we can pass the data to a function using a parameters. So how to see it? So as you see, def, let's see, I have a function, is called greeting. So I'm trying to make it really simple for the very beginner. So sorry for this, but yeah, I mean, I will also add the video, the timing chapters, so you can just jump over the sections that you want. So I can add if statement. I can see hello, and here I need to add the name. And now I have to call, to use this function, as we said, we need to call this greeting function with the name, let's see, Alex. So here the name is a parameter, and a variable that will receive a value when the function is calling. So as you can see here, I have this function, and the name, it will be, I mean, Alex, this parameter here will be assigned to Alex. So it means it's like, let's see, let's just make it simple, but it's like name is equal Alex. This will be like this. When we see here, greeting Alex, so it means call this function and give a name, a value as Alex. And now here we see what is printing here. It will be hello, and what is the name? It's Alex. So this is let's just try to do it. So it means hello Alex. If you change the name here, Bob, it will print hello Bob. So you can see it's easy. I think it's really easy. So here we need to the function is passing a value, and it will be assigned to the parameter name, as like, for instance, like this here. Now a function with parameters and arguments. But before this, let's just back to our example. Let me just the old example. I will just add here. I have seen. Let me just. What was the list? So let's see. This is our list one and list two. Sorry, list one and list two. So we need, let's say, to print it without repeating the for loop. So what we have to do here is define the function. Let's say def. Oh, why is going here? Let's define the function is called def, and let's see. You can try to make it the function names. Let's say relevant or reflecting what is the its function, what is doing. So let's say list printing. It's doing the print of the list, and I have here to add list, right? Let me just call it like this, list. It will it will take, let's see, a list and try to print it, and see I have say for x in list, then I have seen print, let's see, print x, and of course we have already covered this, so please make sure that you know all of this. So now I have three lists here. So now what if I want to print any list? I just type this print, let's see, list one. So this will only print list one. So you can see it's 1, 2, 3, 4, 5, 6, 7, 8. Each element. And if you need it for two, I mean, let's see, let's just change the numbers, right? Just to make it so let's say you need to print F3, list 3. You just type this and it will print only list 3. This is the advantage of using a function. See, I have only defined the function with one for loop, and this will do the job. Let's see. Now let's see a function parameters and arguments. Let's explore the difference with how to pass data to a function. So let's say I define the function describe it. Let's see, and here animal type, and also name animal. Let's see, just animal name. I'm trying to keep also the function is doing. I mean, the naming also is really important. Now it's not important, but when you write a big program, so you need to. So I have let's see, this one here. You need just to copy this named and the animal name. So this is complete function. So you can see I have the parameters here. This is the parameter. I have two parameters. By the way, you can define whatever parameters you want. Sometimes, in my case, sometimes it's about 20 parameters when I use, let's say, a config file. So now let's call this function. What I can do is describe it, and I have seen here doc, and see how can I see. By the way, you can see when you just add a comma here, you can see the next parameter is animal name, and you can, let's see, Bobby, or sorry for this name, and here the name, the order is matter. So let me just show you here. I have an animal type. I have a dog named Booby, right? Now see, the order here is important. So if I just change the order and put it here, so it will give you a different result, of course. I have a Booby named dog, which doesn't make any sense, right? So with positional argument, this is called positional argument. The order of the arguments is matter. The first argument in this function is dog. I mean, dog is assigned to the first parameter. Let me go back. So this dog is assigned to this type, and the second parameter is assigned to animal name. So Python, let's see, also allow you to specify the parameter gets a value using the parameter name. For instance, let's see you have the type here. Let's see I have this function, and in here you can also add a keyword parameter. Let me just move. So now I have this function, and with the keyword parameter, what I mean by parameter, I can see here, for instance, I have the just try to press control and space. Control and space, it will give you this list, and you can see here animal type is equal to, and see you can see we have error. Why we have error? Because we have already used the keyword argument. And if we have already used keyword argument here, you have to use it for the all parameters after this. And if you just use it here, it's not needed to use it in the beginning. Hopefully you know what I mean. Let me just do it like this. So if you see here, I have parameter, I mean animal name. So you can see there is no error because I just use this, and this one here, the first parameter, it's before the keyword arguments. But let's just do it with the all. So you can see here, animal type is dog, animal name is Poopy. So let me just change the position of this. If I see, just copy, cut this, and put it here. Do you think this will give us a different result? I will say no, because Python now allow us to order. I mean, this is order. The order here, it's not matter. So if you see, it will give us the same output. I have a dog named Bobby. I have a dog named Bobby. Why is that? Because we have used animal type. So for me, when I'm writing a program, I'm just using I'm using this keyword arguments, and also we had them, let's see, outlines, or let's see, style that we have to use keywords argument. So because imagine you are writing a large program, let's say doing some object detection or anomaly detection, and for this, the new, let's say, the new member or any member can just read the code. He can understand it, even generally what is going on. And the next step here, sometimes you want a parameter to have a default value. So if no arguments is provided, what does that mean? So let's just use the same function. I will just copy the same function. So let's see here, I have the animal type. By the way, you can change the parameter whatever you want. It's up to you. I mean the order. So let's see, the animal type is, let's see, I can give it, let's change the position. Why I change the position? Because when I give this dog, when I give this a default value, Python told me I have to do it also for this. But so I will just move it here till the end of the function. So there's no parameter, argument after it. It won't complain about, let's say, the default arguments. So you can see here I have the argument type, animal type. It has a default value, dog. And if I call now a function, the function, without any, let's see, animal name, and the, let's see, the animal type is not here. So the program by default, the animal type will be Booby, and the animal type, name will be Booby, animal type will be dog by default. So let's see, I have a dog named Booby. So, but here we have no dog, assigned no dog, but this is right. So it will be taken from the default arguments. So it means if you haven't, if you don't specify animal type, it's it's default to be dog. But we can override this by providing different value. So let's say I have this, and here I have animal type monkey. Let's see. So now I have now assign, I give a value for animal type, and also it has a default value. So the default value won't be used. It will use the one that I'm sending from the function calling, from the calling function. So you can see now animal type, animal name is Poopy, animal type is monkey. It won't be anymore dog. So let's have a look. I have a monkey named Poopy. This is just to give you, I'm just trying to give you all the scenarios that you will, let's see, use or you will face. And let's go here. We have arbitrary arguments. So, what if you don't know in advance how many arguments your function will receive? So in this point here we have two arguments. Right? Two arguments. The function has two arguments, and this is the parameters. We see when we call the function, it calls parameters. When we see the the function in the signature function signature, we call this arguments. Now sometimes you have no idea how many let's see, parameters, how many arguments. It's not like you didn't know how many. Of course you know, but let's assume this is too much. So you are reading, let's see, a config file, the configuration of your program, and there are a lot of let's see, parameters. For instance, image size, cropping size. Also, for instance, using let's see which algorithm to use, what are the feature size, what are the network type, and let's see, you have many parameters. Now you can you will not be able, not you will not be able, you don't want to make like this. When you call a function, you don't want to add all of these parameters for maybe 100 parameters or 20 parameters. So the argument, the arbitrary argument solve this issue. So I will give you one example here. So let's say make pizza. I'm hungry. So what you have to do is adding this sign here, asterisk, I think asterisk, and let's see, I don't know what we call this. Let's see, add addition. Oh, no, addition. Let's see, toppings. What you want to be in the top? Let's see, more. Let's see, mushroom or maybe extra cheese, or, and let's see, print here, print making. Yeah, by the way, I'm just use this notebook. It's only for you just to follow up easily. Otherwise, you won't use this, for instance, when you write a program or when you write implement a system or any algorithm. You will use always Python extension. Making pizza with just like this, and let's see for uh, mm, for topping and toppings. You can see, try to make it, for instance, here the plural and here the singular value. And here you have to add this. Is this error or it's not defined? Of course it's not defined. Ah, oh, sorry. I'm mixing between C++ and Python. Oh. Okay, and print. Let's see, print. I will say if and add a string. This is formatting, string formatting. And by adding this topping. So now let's see, make pizza. I will send for instance mushroom mushroom mushrooms. For instance, like this, I just need, and the topping is mushrooms. So you can see it will give you making pizza with the first one. Now, if you have any, I mean the other one, let's see, Kobe, and I need also, mm, this makes me really hungry, cheese. And here you see, let me just remove the first one. Ah, just need to comment this line, the line out. And here you can see making pizza with this. So now this function here, making pizza, has no idea how many parameters I will receive. So that's why we have adding this asterisk. So we use this, for instance, if we have, let's see, some to process some inputs data. Sometimes I will send 2 images. Sometimes I will send 3 images, 4 images, 10 images. It depends on the, let's say, the capacity or the stuff in the queue, or maybe you will send some data from a file to process this line, 2 lines, 3 lines, 10 lines, and etc. So you didn't need to add here. So the advantage of this, let me just go here and imagine without this, what you will do. So you'll see topping, let's see, topping 1. Then you will see topping 2. And you will have to add 3. You will have to add 4. And etc. See how many parameters, how many arguments you would have. So this solve our problem, make our life super easy. This is I will see. So the asterisk before toppings tells the Python to back all the positional arguments into a tuple named topping. So in this case, we have using tuples. So if you try now to modify any value, it won't give you. It will give you an error. To try to use it, please. And this allows the function to accept any number of arguments, any numbers. And if you add here, let's see, green peppers, and you can see I have also 1, 2, 3, and I can add many, let's see, parameters as I want. So this is the advantage of using the arbitrary arguments. Okay, let's move to the next one. Is arbitrary keywords arguments. See, there's a difference here. So here's arbitrary arguments, and here arbitrary keywords argument. So similarly, you can accept an arbitrary number of keywords arguments, But let's see, let's define the function. Okay, let me just think. What should be the example here? I mean, when I wrote this, I was thinking on an example. And let's say defined build profile, first, last, first name, last name, let's see, and also user info. And you can see this is with single asterisk, and this with two with double asterisks. Now I have this. I can see user info, user info, this one. That's the same. So user info, I can see first, no, first name, or maybe like, because it's a key, so we need to no space, try to avoid the spaces, and it will be first. Why it has error here? First, oh man, so I forgot this comma. So for the, I also give the last, and here we need also the last name, last name, and we can return. Okay, I haven't talked about return value, right? Okay, this is the section. Yeah, I can explain it later. Let's see. User info. So now to call this function, it's now a function, and they have the first name. Let's see, Alex, and the last name. Any name. And the info, user info, will be, let's see, any arbitrary number. Let's see, age is equal 30, and maybe let's just use this, and let's see, print argue user, not user. We have to, because it's returning a value, we have to use info. I can give you, we will discuss the return value, but sorry for this, it's my mistake. Let's we have a info, and we have printing now, and you can see here age is the 30, first name and last name, because user user info in the beginning it was, let's see here how many parameters do we have. We have 1, 2, and this is argument, arbitrary keywords arguments, and this it's give it will take the number of parameters. Let's see all the parameters after the first two, because here you have 1 and 2, and the keyword argument is only the third one. So whenever you have, let's see here, I have job is equal engineer, and as you can see, I can also add here first and last. So you can see I have first and last, right? First and also last, but I have no age and job and everything, because I have used user information. This will save you much time. So let's see here, I have age, job, first name, last name, and etc. You can add parameters here, as much as you can. So this is the arbitrary keywords argument, this example shown. But we also have, in the beginning, we have seen this printing, let's see, example here. We have, as we said in the beginning, there are generally two types of function. Doing the processing in the same function as we have done it here, or returning value. So let me just add here one example with returns values. So far our functions have just been printing values except the one above, but functions become much more powerful when they return values that can be used elsewhere in your program. So let's somehow add a function def add numbers. So I can see A and B and return A plus B. So the return, let me just add, so the return statement send the value back to the code that called the function. So here, let's see here we have seen, let me just call the function add numbers, and let's see 8. And you can see here I'm adding I'm calling the function with two parameters a and b, and a will be 5 and b will be 8. So it will be 8 plus 5 plus 8 would be 13. Now but you can see here it's returning a value. This we have to let's see if this returning value in one parameter in one variable. So oh man, so when I run this, because if you as you can see here clear, so it's just printing the the number because it's the last one in the cell. But if I say maybe, I'm not quite sure, but let's see print, let's see hi, I'm not quite sure if it will be print 13 because I'm not using let's see notebook heavily in my daily life. So you can see it's not printing. So I'm not using, let's say, the returning value till this point. But why it was printing? Because it was the last sentence, let's see, in this cell. So now we have here we have a return value. Now we need to use this return value. So here we have calling the function, and before this we need to see if the value in this, let's see, result equal. So the return value will be assigned to this result. Okay, so now if you see print, of course it won't print, only print high, but if I print now result, it will be 13. Someone will ask why I just return it to the main function. This called, let's see, a main function. This is the body function, and this is the calling function. It's not the main function, obviously. And we just have printed the value. This is just to show you how to return the values from a function. And this value, for instance, this results, you can use it with, let's see, for maybe you see it's equal results minus 10. So you can see here I can use the result value, and you see here print result. You can see here is printing 3. So this means I can still use the returning value from the function. This is the idea. Now sometimes we have multiple return values. So Python can return multiple values at once. So in a C++, you can return, of course, you can return a vector, you can return a matrix, you can return, let's see, class, object, and whatever. But let's see, in a Python, you also, of course, you can return two different values. So let's see def get name. Let's see without no with no arguments, and I see here I defined some variables. First name, so for instance Alex, and last name is equal to. So, and you can see here we have written in this function, we have written only one value. It's only one value, this plus this. It will try in the beginning, it will do this operation and return the result. And here we have seen, let's see, return first last. So here I'm returning two values. Okay, so you can see here how to get this value. We can see get name. We have this function, and of course if you print this, it will return Alex and Bob in a, let's see, in a table. But let's see if I print this, because it was in the last sentence. Let's see the line in the cell is printing Alex. But if you see print any thing and run this get name, or let's see Alex and dude won't be printed. So we need also, as the first example, we need to save the result in a variables. Let's see last, this is last name. So here I'm returning a values, returning 1 2 and saving this in these two variables. So now if you see, if you print first name last name, you will get Alex and dude. Okay, so when you return multiple values like this, Python actually return them as tuple. So we already said, and it can just we then unpack them in this tuple into a separated variables. So we already have discussed this in the tuple, let's say, video. I have explained everything in the tuple, also list dictionaries and everything. So let's see the scope parameters, variable scope. There are two types of variables, local variables and also a global one. So the local one, I can only use it inside the function, let's see. And the global one, I can use it everywhere. But please, this is just a hint. Try not to use global, because global you will if you let's say implemented large program, large system, and you have this global variables, and at a certain time you will see this variable is changing. The behavior of the system is different from the expected behavior, and after a while you will detect that this was caused by the global variables. So try not to use global variables, but sometimes it's needed, you can use it, of course. So variables defined inside the function are called local to that function. So let's have a look. Let's see def. Of course you can use function. There's no let's see specific constraint function. So let's say I have this, and inside this function I'm trying to use x is equal 10. So, and here say print x, this will print of course 10. So now this x is called, is constant as local variable only on this function, so no one can use it. So when I say print now function, so you can see it will it will go this function, calling this function, and it will assign x to 10 and print 10. Oh, sorry, I have to add this. It will print 13, right? Now, if I see, let's say print x, let's say print x. X is here, right? It's defined here. But as you can see, it's considered as error. So x is not defined. Why it's not defined, but it's here? This because it's considered as local variable to the function. And you can see here, name x is not defined. This is called local variables. It's only seen inside this function. It will be, let's see, as abstract. I'm not sure if this is the right word to say, but the variable x only exists inside the function. And if you try to access outside, Python will give you error, as we have seen. So let's say function, just like this, and you can see here it's printing 10. Okay, and now let's move to the global one. And the two aspects for the global variables. So the variables defined outside any function as a global and could be used inside any function. Let's see, inside let's say the file. If you defined, as you can see, for instance, I have defined where's the list? I have defined some list. So okay, it's deleted. Let's say I'm defining a variable here called global variable. Global var is equal 20. So as you can see now, I can use this variable here. So if I see now print, it will give us 20. Why is this? This because it's this notebook is considered as one file, and because it's already defined up, it's used as a global. Let's see. And I'm not quite sure. Let's just try to define here. I think it should work, but I'm not quite sure because, as I said in the beginning, I'm not using Python. Let's see, notebook heavily. So if I see, let's see, var x is equal 80, and try to print it here before. I think this work, but let's just give it a try. Var x, yeah, it's used until as it's read. Let's see, read by the system, it will be considered as defined. You can use it wherever you want. Okay, so this is the global function, but let's give a function, a variable equal 50. And now I defined my function, def my function, or y function is fine. And now if you see print y, as we have seen in the beginning, it won't give you any error. So y function, so you can see, oops, I have now 50. But let's see if I see here, if I add here or print y, with y, it will print 50, right? But let's see, assume that I'm trying to say y is equal let's see, plus equal 50. So the answer here, the printing here will be how much? the output here will be 50 plus 50, right? And it will print 100. But what do you think? What should be this parameter, this value here? Will it be 50 or 100? If you see 100, it's wrong. It's wrong. And I have to, okay. I have to indeed define it as a global, but this is the next step. Let's see, clear this. And if you see, for instance, here, 1y is 500, and this will print here 500. And what do you think will be here? It will be 50. Why? Because the program here is considered as y as a separated value. Let's say variable. It's different from the y in the global here because we have defined another y here. But if you just use it, no. If you just use it, you can see it's printing. Now, sometimes I need to change this value here. Let's see, as we have seen in the beginning, it gives us error. This is was the next step. So sometimes I need to change the global value. This is was what I said in the beginning. Try to avoid the global, because imagine you define the y here and you change it somewhere else in the function. It will give you, let's see, many troubles. So the modifying the global variables, it will be, let's see here. So let's say we have a variable z value, and here we define the function def modifying modify global modify global, and let's see here, let's see z is equal 40, and it's now the same example as this one here. So let's see print. Oh, we have to add, let's see, print z, and here we call this function modify global, and here we have, let's see, print. We need to print the z. Now it's the same example as above. So this will be considered as a local variable, and this is the global one. So this will print, this call will print 40, and this will print 90. So, but you told us we can modify the value. Of course we can, by adding global. So you can see global z. So inside the function, you need to add this keyword global. So by adding, to modify the global variable from the inside the function, you have to use global keyword. So without the global declaration, without this one here, Python will create a new local variable named z, instead of modifying the z. So now let's see, I see now z is equal 800. So when I call this function, with this calling here, it will try to print 800. And what I expected, this will be printed. When I see print z, this z here, it will also print 800. Why? Because we have used global. You can see 800 and 800. Oh man, it's already 1 hour. It's too much, I will see. Let me just make a short break. Okay, now we will continue from lambda. So what is lambda indeed? So lambda function, it's let's see, lambda functions are small functions defined with lambda keywords. So for instance, let's say you have defined lambda function like square square. This is lambda lam lam lambda lambda. You can see lambda function as x. For instance, let's say we need to uh, find the square value of any value. So now here I have, it's like a function. It's like defining this function here, and here you need to use it. For instance, the square, and let's see, I need one square. This is the right one, square. So here, when I see, if you see this function or any function, when I call this function, it will try to implement whatever in this function and give you, let's see, printing or give you a return value. Now here is it's like a constant function, a small function that's doing, let's see, a square value. So when I see a square, and now I define this, and I call this square and see and 10. This will print it, saying it's in a German language. Sorry for this. And square, and you can now print square. Oh man, I have to add this indeed. Print square. And if you see now, this will calculate, let's say, the square of 10 and return 100. And let's see, just give you some sentence about lambda. Lambda functions are limited to a single expression. As you can see, I have only a single expression here. And are typically used for short, simple operations, especially with functions like map and filter. So let's have a function, let's see, I have a list here, nums is equal 1, 2, 3, 4, 5, 6, 7, 8. No, 7, 8. So here squared, I need to, let's see, to find the squared value of each element in this list. So for this I can use the list, I mean the lambda function. So I can call this, I have said this will used typically with map. So to do this, we need to add map, and we can add now the lambda. Let's see, we need to use square. So let's say like this, and you can just put it here. But I will show you how to do it in a different way. And here I have nums. So if I now print squared, now should give you 1, 4, 9, 16, 25, 30, 63, 36. So, oh, yeah, see, I have now indeed a map, and this has to be converted to a list. List. So, here we go. So we have 1, 4, 9, and everything. Now, because we already defined the square, the lambda here, we can just use it directly here. So just use square, this one here. So the square is defined here, and I can also directly use it, and it will give you the same result. See here, it's the same. So again, lambda is used for simple short operations and also for single operations. So you can't combine any. Let's say you need to make this square for each value, then adding 10 plus, let's see, minus 20, and let's see just several operations. This won't work by Lambda. Okay, so now let's go to doc strings. Doc strings is a good documentation. I mean, sometimes when you write a full system, let's say a complete system, I recommend you to use doc string. It's a good documentation. I mean, good documentation is essential for readable code. Python use doc string to document, let's say, strings. So let me just show you how. So let me, and also, let's say you wrote the code in before 2, 3, 4, 5 years. And when you back to this function, you will understand 100% that what is going on and what is it's doing. But if you just add it randomly and type it for quick for prototype, so you will need to read the script, the whole script, just to understand what is this function is doing. So I'm just give you my let's see 8 experience in German industry. So let's see add. I have here add a b. So I have a function to add. Let's see. It's not clear now. It's add just add function, and it has 2 arguments. And now how to add the doc strings? So you can add by 3. Oh wow, wow, wow. See, if you add 1, 2, 3, and so you can see here, generate doc string. It's already provided inside. So you can see here, this is a summary. You have to write what is the function about. So let's just remove this here, for instance, and add our comment, add 2 numbers, and return the result, only result. And here the argument, it's the type int or float. And the description, let's see, first number. And the description for this is second number. And the type, of course, it will be the same, int or float. So now here we have defined, let's see, the what's this? The how's the program is let's see what is the program is doing. It's receive arguments 1, 2, and this is the description. What is the function is doing, and here you can see returns. So no syntax here. It's the there's no syntax in this doc strings. So you didn't need to follow any let's say syntax. So it will return int or float, which is let's say sum of a and b and b. So finish. Let's see finishing the doc strings. It's finished. Now I will see return a plus b. Return a plus b. So as you can see now here, if I give you a program, let's say, or a system that every function is doing like this, you will understand every function even without running and debugging. Just to understand it with this, okay, this is as 2 numbers and return the result. It's absolutely clear. And let's see, you need why we have used this. Sometimes you need to add, let's see, help. For instance, print. I have add function. This is the function name, and I see dot doc. And if I see now print me the document the string of this function, it will give you here what is the inside, what is the documentation. And from this you can also generate how to use a document for your function, for your system. This hopefully we will learn also in this course. my goal is to give you my whole experience in this industry, and so I'm trying to give you what I have learned over these 8 years. Hopefully, it will help. Let's see. Of course, it will help. It also helped me to remember all of these things. And you can also use help and add the function here. So let's comment this. Sometimes you have a function, and let's say this is the add function. I need to a help function. I mean to get the help. How to use this function? What is this function? So you can see, just if you click here help, so you can see help on a function add in module name. This is the main module. It's considered as one file, as I said in the beginning, and give you the doc strings. So let's see if these are not here. It will give you nothing. Just give you the function, the signature function with arguments. That's it. Wait. So let's see. We have to use this. Maybe it will give some error. I don't know. No, they just give you none. There's no documents. So yeah, this is how to use. Let's see the Docker strings. It's really helpful, and try to write it for, let's see, for you, for in the beginning, for you, not for the, let's see, for the your colleagues. It's for you. From my experience, sometimes when I write, I wrote a code 1 week before, I have to let's see, go through this code and see what's going on. But if you use this Docker strings, it will give you, for instance, what is this function is doing. So Docker string is includes the trouble. Let's see, quotation. This quotation is here. It's includes in this, and should be described what is the function does, its parameters, and also if it returns some values, and this can be accessed using doc, and we have seen help. Right now, let's see, we have a recursive function. Let me remove this. So now we have a recursive function. A recursive function is one that call itself. So I'm quite sure that you know how. I mean, you already hear about this factorial n, and we can see if n is equal. Don't forget this equal 1, then return 1. Else it should be else. Oh, return typos always. So now return n times factorial. See, we have called the function itself, and -1. So what is the factorial indeed? The factorial, let's see, if you have 5, let's see, comment this. If you have number 5, you need to calculate the factorial. The factorial is 5 times 5 minus 1, 4. 4 minus 1, 3. 3 minus 1, 2. And 2 minus 1 is 1, and it's enough. So it's like 5 times 4 times 3 times 2 times 1. I think it will be 120. I'm not quite sure indeed. And let's see, print factorial with value. Let's see, 5. And yeah, so you can see factorial is just a function, and if it's let's see, I have here 1, I mean 5. So now it will be to I mean with this condition here, if 5 is equal 1, no, it will come here. So it will be 5 times factorial minus let's see, n minus 1, which will be 4, and it will go again to this one here, and the input now it will be 4, and it will be here now 5 times 4, and then call this with 4 minus 1, it will be 3, and it will be again here. It's like a for loop indeed. Recursive function, and you can see here, if you print, it will give you a value. I mean, the result. Try to write it in a for loop. Sometimes the recursive function is really cost much time and I mean resources. It depends on also in the function itself because it will save all of these sequences on the memory. Okay, now let's move to the decorators function. Decorators are the powerful features that allow you to modify the behavior of a function. So sometimes, let's say, assume that you have a function and you would like, let's say, to calculate the time of the running, any running function. And instead of calculate, the time for each function, the time for each function inside the function, just try to create a decorator function, and it could be used by, let's see, this function. So let me just give you, for instance, one example here. By the way, the decorator, it takes a function as an input and also adds some functionality and returns the new function. So let me just wait. Okay, so let's just apply this how to calculate the time. To calculate the time, indeed, you need to import time package, and to calculate, let's see, the time, you can start with easy. Let's see, import time dot time, import time. Okay, from time import time. Just not use time dot time dot time. So how to for the sake of simplicity, let's say start time is equal uh, time like this, and let's see, here's your code, and here you see end time is equal time. Okay, now when you enter this block here, it will start to give you the time as a timestamp from your system. Now, executing whatever it took here, it will calculate it as you see, running time, and when it's here, it's calculated when it's finished. And to calculate the time, you can see, let's see, calculated time, or let's see, running time is equal end time minus uh, start time. Start start time, and this will be in a second, execution time in seconds. Okay, so now let's do this in a with the help of a decorator. So let's see how it will be organized. So let's say define the function def time. Let's see, I time, and I have here, as we said, it's receive a function. Sorry. Okay, so now you can see it's receiving a function. Okay, now we need a wrapper function. So it's like a function inside the function. So wrapper function. I mean, this is not needed to call it wrapper. You can call it whatever you want. So now let's see. I have arguments, args, args. Then I have the keyword, keyword args, keyword args. So we already discussed this in the beginning, so hopefully this now is clear. I have already deleted this time start, and let me just go back. Sorry, I need this indeed. just but to write it in a function. Okay, so this is the function, and you can see here is start time, and also I need also the let's time. Now I just type, press tab just to move it into the function to align it in the same function. Now let's see, yeah, it has to be indented in time again, yeah, like this. So here you see we have the function, and let's see what we have done here. We will see, we will call this function here, this function. So you can see result, we got result is equal function, and we can add these args and also key arguments like this. So whatever it takes, it take this function, and let's see, just make space somehow to make it clear. And let's see, we can also print if, if should be out, if running time talks about running time seconds, and here we see return result that will be calculated by the function itself. Let me just complete this, and I can assure this you will know what is the return rubber function. So this is this called a decorator function. It's receive a function, and with this rubber function it will call the function from here, but let's see, we will need to calculate the time. So let's now define the function. To define the function, we will follow the same structure. Let's see the same syntax. Let's see my function. By the way, this is function decorator is really advanced topic, and if you understand this series from the beginning, I'm quite sure you are a hero. Let's see result. Nah, result is equal, for instance, 1, and now we have, let's see, a for loop to calculate the time and to see the difference. We need, let's see, how somehow a for loop. So let's see, for I in range, because here the function is receiving n, we can see n, and here you see result times, multiply I, this I times, plus 1. So here we have result 1, and for each time we will multiply the result times I plus 1. So for instance, 1 times 1, and next 1 times 2, it will be, the result will be 2, and 2 times 3, and etc. And let's see, return result. Okay, so let me just try this. If I see my function, so let's see, print uh, print let's see 5. So now this will call this function, right? And this will call this function and returning the result. That's it. It won't take, let's see, run this, and I will show you how to use this. So let's say run this, and you can see it's return 1. Why it's return 1? I have here 5. it's strange indeed. Print result, just to see what is in result every time. I think it will be 111. Yeah, of course, 1 times any number it will be, but oh man, okay, I have written inside the for loop, which is really bad. My mistake indeed. So return has to be only with after the, let's say, the for loop, unless you have, let's say, a break, or if you, for instance, see till this point try to break the for loop and return the value. And I think I already covered this for the for loop. So now let's run this, and you can see 100%, 120. And if I see now, if I add this here, let's see, to add the decorator here, this is the function I have called this, and you can see I have this time in, right? So what will be printed here? You can see it's really interesting. Running time took, it's because it's only 5 numbers, and give you also the result. So the output is the output of the function itself, because here we have return value, and also the running time. So how this is running indeed. So the decorator, it takes a function as an input. So uh, this is our function, right? And once we have added this here at time, I mean the decorator function, this is, let's see, somehow generally taking it will call the function the decorator function, and the decorator function will, the input parameters for this func, it's this here, my function, and it will start, it will be in here, it will go directly, for instance, from func, it will directly go to return wrapper, and from return wrapper it will go directly to return wrapper and see what is the input, I mean the input parameters and everything. We'll send it to the function itself, and because we have only 5, it will be here 5, and we'll return the result, right? And here calculating the start time, and here calculating the end time. Running time calculated by the difference of this end and start, and it will print this. Now it will return the result. The result will be returned from this function to here. It's like this, running this function indeed. When we see run this line here, it's like running this function. Hopefully it's now it is clear. So let's increase the number of 500. Let's see, now you can see somehow some difference. It won't work. Let's see, we can add sleep indeed. So you can see it takes much time. Now you can see running time took about 2.5 seconds. So this is the idea how to use the decorator. See, it's changed the behavior of this function. My function is just doing multiply the result by the range of these values. That's it. I mean, only in this example, so for instance. Now, as we have seen, we have added some behavior to the function, which is calculating the time, and also, I mean, calculating the and also printing the final time. So by the way, without this decorator, you have to add this block of code, I mean this, without this one here. Indeed, I have a mistake here, bug. we have to return result. Uh, yeah, for each function, if you don't use a decorator for each function, you have to use this for each function. So for instance, this it will be start time, end time, and the difference, and etc. And for each function. But we wrote it. We have written this one time, and to use it, we need just to use this time dot. The decorator function itself. Okay, cool. This is, let's see, really advanced. And also the generator, it came 100% in a interview questions. So generators are a function that can pause and resume their execution. How? So the yield, because let's assume that you have a big file, and or maybe you have a folder that contains thousands of images, just for example, and you will not be able to load all of these images in a memory, right? So this generator function will help you to do this stuff. It will try to read the first, let's see, image, let's see, for instance, image by image. It will read the first image and give it back to the program to for execution, and do the for loop again. So with example, we can see how it's working. So let's see, we need to count till just diff count up up to, and we have to give a parameter here. Let's see, n. Now count, just define the variable count. Let's see, count 1, and here we need to use while count less than n, or let's see, use this max. It's better. Use less than max, less than or equal, indeed, max. Now I see count plus equal 1. So this will increment the count every time, every iteration by 1. So let's see here, I have yield. This yield has to be added here. So count, I have to yield count. This is how to use the generator. We use the generator by the difference between of any function and the generator, we use yield. So let me just show you how this is working. So counter, it's count to up to, let's see, 10. Count up to 10. So now if you see for I, or let's see, num n counter. So you can see now this count up to 10, and here is counter, right? And here I have this counter, and if you see print num. So how this will running is, if I just show you here, you can see 1 2 until 10. Then how this is working, I can explain it very easy. So you can see here's this is the function, and the function, as you said, generator has yield keyword. It's a keyword, and it's like return. But what is the difference between return and yield? Return, it will stop the program. If you add here return, it will stop the program, the execution. But yield, it will try to return this value to here and continue with the file, with the while loop. And for instance, let's say starting with 1, it will send 1 back to here, to this counter, and we will print 1. Then it will continue by default, count plus 1, it will be 2. And again, is count less than or equal max? Yes. Then yield count, it means return this count back to the function here, to the for loop. And you can see here yield keyword returns a value and pause the execution, the function execution. It will return this value and wait until this is finished. This execution is finishing. Let's see. I'm not quite sure. Let's see. Let's we have from here we can see from time import sleep. So you can sleep so for some seconds. Sleep now. Sleep. Yeah, of course it will wait for the execution. It will stop the execution until this for loop or function is finished and returning back to this. So again, here's the count is 1. I mean, this is the function of the generator, and here I just call the function with 10, and this won't be executed. Indeed, this won't be executed. Let's see, only here. And when I see num is equal, I mean num in counter, and I see the counter itself, it will call this function. The function will with 10, and the first time it will be 1, return count 1, and stop here for several, I mean until finishing this function here. So if I see sleep, let's see 20 millisecond, and I see here, you can see it's 20 seconds this one. Cool. So you can see, yeah, it's good, I mean, to see the difference. So now you can see it's returning 1, but it stopped here because the for loop it's need, let's see, some calculation. And after finishing this, it will give you the next item 2. And after finishing the 20 seconds, so the sleep is 20 seconds. In a C++, it's a millisecond. Interesting. Okay, this is just I want to show you how the generator is working. So as I said, imagine you have 1,000 image, and you can't load all of these images in once. You can just read it one by one and return, let's say, the image here, do the processing, and finish. I will stop this because 20 seconds is too much. But I think you already know that. Cool, I can't stop this. Nice. Not restart. Okay, there are a lot of stuff is indeed here. I'm not quite sure if I can cover this in this video. It's already almost 2 hours. I don't know. Maybe I can do a second section indeed. This is enough, I would say. But let's just close this with best practice. Try to use a descriptive functions name. So if you calculate, let's say the average, so call the function calculating average. Calculating, for instance, price, total price. You can use this, and it should indicate, let's see, what the function is doing. And for instance, add, it's adding 2 numbers. But if you call this as function, my function, your function, blah blah blah, x y, it won't be, let's say, readable. And keep function and small and focus. Every function has to be doing only one stuff. Let's say, for instance, if you have building a calculator, so you have plus, minus, divided, and multiplied, and each function has to do only one step, only one operation. For instance, sum, it has to do one sum. Try. Someone will say, I can do one function, and I see if it's multiply, then do multiply. If it's plus sign, plus, I mean the sign is plus, do this, which is it's boring. So try to make it small, and if you have, let's say, a bug or issue in one function, you can fix it only on this function. you won't touch all of these functions. But if you have just make it rubbish, it will take, I mean, it will be fast to do all functions in one function, but it will take you some, I mean, huge time just to recognize where is the error. And try to use also docstring just to show you how the help, and consider as a numpy Google, and if indeed every package has numpy. I'm also restricting ourselves to use docstring. Limited number of parameters, used to 3 or 5, I mean 3 to 4. More number of parameters, you can save it in a dictionary, you can save it in a list, you can save it in a table, and etc. Avoid modifying mutable arguments, and this can lead to unexpected behavior. And also try to avoid, again, try to avoid global variable. This is my, let's say, perspective, because it's changing a lot, and I mean, I had some issues with this. Return values consistency. Oh, this I haven't covered yet. So this, if you have a for loop, if you have a code, and for each condition you have to return a value. Let me just give you one example. Let's see, for instance, for I in range 5. Let's define the function. Defined param. What is this? Param? I know, no idea. N. And let's say I have here for loop, and I have here n. Now if I see, let's say I need if I is equal 0, return false. If return false, and else, let's see, lf, just keep it like this, lf lf I is less than 1, return negative value. No, you have to return false, for instance, false. Now let's see without, let's see, for loop. Just want to show you this. So if I can just change it to I, now you can see. And what about if it's not this or this? So now you can see I have print parameters with 8, right? Now you can see 8 it's not equal 0 or not less than 1. So, but we need somehow, this function is not working well, because why? Because here it's returning and here is returning, but when it's not 0 or 1, it has also to return something. So if you see print none, but if you see here return true, let's see, now we have true. This is returning value consistently. All code paths should either return a value or none. You can also return here none, depends on your stuff, let's say. But this is just to show you every path. See, you can see here, this is one path, this is the second path, and this is L, the third path. So every path has to return a value or none. So you use to type hence for better coding. just try to use a documentation. Follow the try. What is the try? It's don't repeat yourself. So one hint, I mean, it's not one hint, but it's one device. If you see you use one stuff more than, I mean, more than once, your code is rubbish. So let's say I have used a for loop 2 times just to print list. So no, I have to create a function, and I use function wherever you want. So this called don't repeat yourself. Try to use also meaningful parameters, and also provide the default values when appropriated. Default values already covered. I think this is enough. I will try to cover the next, which is really advanced functions and tutorials, in the next coming videos. And also I have here some interview question. Was the difference between generator and regular function? What is the difference between arguments and keyword argument, and also the somehow quiz, and I have the solution. So this we will see it in the next part 2, let's see. Okay, so if you like this video, please subscribe into my channel, like the video, and any if you have a question anytime, just drop comment below, of course, and I will answer it. I mean, when I see it, of course. Okay, thanks for watching, and see you next time.